Assalamualaikum dan salam sejahtera. Boleh dengar saya?
Boleh, Doktor.
Okey, boleh. Terima kasih. Okey, so saya rasa saya mulalah ya. Okey. So sebelum saya mulakan majlis ni, kita buka majlis kita dengan bacaan umum kitab Al-Fatihah. Thank you. Assalamualaikum dan salam sejahtera. Okay. Terutamanya saya sangat berterima kasihlah kepada penceramah jemputan industri kita pada hari ini, iaitu TS Khairul Syahir bin Hashim daripada Sarawak Metro. Sebelum saya cerita lebih lanjut berkenaan dengan kita punya panel ni untuk hari ini, saya akan beri sikitlah dia punya dia punya cakap resume lah, macam tu lah, biodata dia. So saya terima kasih jugalah kepada pelajar-pelajar khusus BNT 20403 Instrumentation and Control dan juga BNT 30903 iaitu Electrification Railway Railway Electrification System yang dapat hadir untuk program pada hari ini. Dan terima kasih juga kepada jemputan yang lain lah yang dapat turut serta mengimarahkan lagi majlis ilmu kita pada hari ini. Kita tahu bukan mudah lah kita nak dapatkan temu janji dengan TS Syahrir ni. Dia orang sibuk sekarang ni. Program untuk art ni tengah berjalan sekarang ni ya. Okey, so saya akan beri sedikitlah biodata berkenaan dengan TS Syahrir ni. Betulkan saya kalau saya silap ya. Okey, TS Khairul Syahrir bin Hashim merupakan senior manager di bahagian sistem assurance and requirements daripada Sarawak Metro dan telah bekerja selama 3 tahun di 3 tahun di Sarawak Metro. Beliau mempunyai pengalaman luas dalam bidang railway. Tak silap saya lebih daripada 10 tahun ni kalau saya tengok dia punya biodata ni Dia juga merupakan graduate Universiti Tenaga Nasional kan?
Betul.
Okey, dan juga merupakan alumni UTHM juga. Okey. Selain daripada menimba pengalaman di Sarawak Metro, dia TS Syahir juga pernah bekerja di Alstom di Riyadh, Arab Saudi sebagai di bawah sistem design requirement. Okey. Pernah bekerja di Sapura sebagai manager sistem requirement, di Arakan manager sistem requirement dan juga MMC Gamuda KVMRT. So kalau kita nak bacakan banyak lagi ni, memang pengalaman dia semua on rail je. Company yang terlibat dengan TS Syahir ni. So topik kita pada hari ini So hari ini kita akan dengarkanlah perkongsian ilmu daripada TS Syahir berkenaan dengan Introduction to Hydrogen Mobility, Hydrogen Fuel Cell, Powered Autonomous Rapid Transit ataupun ART, dikenali sebagai ART, for Kuching Urban Transportation System, KUTS. Okay, so saya harap pelajar dapat mengambil segala ilmu sebanyak mungkin yang boleh, dan jika ada soalan nanti di hujung kita boleh kemukakan kepada panel. So tanpa membuang masa lagi, saya serahkan kepada TS Syahir untuk berkongsi ilmu dan pengalaman beliau dalam bidang tersebut. Okay, silakan.
Terima kasih Dr. Zu untuk opportunity given untuk menyampaikan sedikit ilmu lah pagi ni berkaitan dengan hydrogen mobility. Pada semua harap dapat menimba sebanyak mungkin. Saya akan share lah, kalau soalan nanti kita akan cuba jawab di hujung presentation ni. Right, boleh dengar Dr. Saya testing suara dulu, okey ke tak?
Boleh, clear, loud and clear.
Alright. Okay, Assalamualaikum and very good morning to everyone. Allow saya untuk cakap dalam, saya mix lah conversation ni, English and Malay. Right, thank you Dr. Zu, thank you kepada HTHM, kepada semua for giving me and Sarawak Metro for opportunity to provide insights of to the hydrogen technology. So as presented, today I will present on the introduction to hydrogen mobility, hydrogen fuel cell powered autonomous rapid transit atau ERT for Kuching urban transport system. Right. Okay, secara keseluruhannya saya akan presented according to 4 parts. Saya akan cerita sikit on the Kuching urban transport system, and then why hydrogen, a bit of a principle of hydrogen fuel cell, and the hydrogen fuel cell powered autonomous autonomous rapid transit for Kuching urban transport system. Okay, Kuching urban transport system, KUTS. In KL, we have MRT, LRT, monorail, KTM, commuter, and all rapid KL buses. So by 2025, we aim to have Kuching urban transport system in Kuching, Sarawak. All right. Maybe a bit of aspiration of Kuching urban transport system, KUTS. We want to relieve the traffic congestions. We want to improve productivity and quality of life. Yes, we want to increase the accessibility by linking residential, commercial, industrial, public amenities, parks and greens, as well as places of interest. KUTS aims to be a catalyst to economic spillover, creating opportunities, enabling trade, and facilitate access to market and services. Yes, we want to lower the Kuching city's per capita carbon footprint and transport-related population. Okay. On the next slides, Kuching Urban Transport System Project Government. For your information, this is under the purview of Ministry of Transport Sarawak. KUTS is being implemented by Sarawak Metro. We are the only wholly owned subsidiaries of Sarawak Economic Development Corporation, SEDC. So on the screen right now, you can see a transit map. This is transit map of the entire KUTS. Currently, you can see in the blue, red, and green color, this will be the phase 1. So for the phase 1, we have Rembos to for Blue Line, we have Rembos to Ikma Exchange. Ada 15 station dekat situ. So total will be 27.6 kilometers. Red line ada around from Kuching Central to Pending. This will cover also the station of airport, Kuching International Airport within red line. 7 station there will be 12.3 kilometers of length. And last we have green line. So from Pending to Damai Central with 9 station and the length of 30 kilometers. Okay, mostly the alignment will be at grade that cover the length of 69.9 kilometers. So technically, KUTS just embarks its journey, baru je start ni. So as you can see, those in grey tu semua is a provision for future expansion for Greater Kuching, right? sedikit on the roadmap. We started our journey on 2018. Completed of feasibility study for KUTS. We commenced environmental, social, and heritage impact assessment on 2020. Right now, and then we continue with scheme design, infrastructure detail design, and system design for 2021 until 2022. And right now, at this current moment, we are in the final design stage for system works and detail design for the rest of infra works. So 2023, we can see that in the news, the prototype ERT is currently available in Kuching for the proof of concept exercise. And for your information, construction works already started at our Rembus depot. Soon it will start the construction at the entire of alignment. Okay. We plan for completion of Blue Line Stage 1 in Q4 2025, and then completion of entire Blue Line together with Red Line in Q4 of 2026. And we hope the KTS Phase 1 will be completed with the completion of Green Line in 2027. Okay. A bit of autonomous rapid transit operation. Okay. We have all the conventional railway system, such as signaling. Here we use the signaling CBTC. We have automatic fare collections, automatic fare platform gate, we have public address, passenger information system, SCADA, wireless communication via LTE. This will be the first in Malaysia, all right, or even Southeast Asia. Okay, and then to support the first and the last mile of KUTS, we have the H2 feeder bus. And then the operating headway will be 8 minutes between one ERT to another, and it will be operated at dedicated ERT lane. Okay, of course, it will be operated with some around 61 intersections because ERT is like a tram. It's like a smart tram. We will cross some of the junctions. Okay. On ART stations. Okay, the station itself is a people-centric design. We have laybys for passenger drop-off and pick-up. There will be overhead of pedestrian crossing equipment with lift, washroom, station, and it will be OQ friendly. Okay, and then we try to adopt the cultural elements into the structure of the ERT stations. Kita ada local Sarawak cultural motif. Alright, Ruai concept untuk elevated station and Teratak concept untuk at-grade station. Kita akan ensure there is a safe and secure operation of KUTS. All station is secured with CCTV and operated with the state-of-the-art operation. Right? Okay, now we move to ART H2 vehicle. This is a zero emission. It will be operating trackless with no rail. Okay. Single refilling for this bus, it can travel up to 300 kilometers, and 300 kilometers it will be zero emission. The only emission yang ada ialah air and then ada heat sikit lah. Okay. The hydrogen bus we have for the journey planning, we have the H2 bus mobile apps. There is a live GPS as well as high-speed Wi-Fi on board. Okay. All right. Introduction to hydrogen mobility. Okay. The question is, why hydrogen? So as everyone already aware, we are experiencing a global warming right now, and everyone is talking about sustainability, ESG, and green energy. So this is all the impacts that you can see on the screen right now. And we have to start now, right now, for the betterment of tomorrow. Okay. So basically for this, we have two targets that we have to achieve. The first one is a Paris Agreement. So Malaysia is one of the countries that already signed the agreement. Okay, on December 2015, together with another 196 countries, Malaysia is one of the countries yang signed this agreement. And then by implementing the hydrogen fuel cell powered ERT and hydrogen fuel cell powered feeder bus for KUTS, Sarawak is on its way to fulfilling the Paris Agreement and to achieve the net zero carbon emission in transportation. Okay, jom bersama kita be part of this movement untuk kebaikan hari esok lah. Okay. Number 2, for Sarawak Green Hydrogen Agenda. So it is a plan by Sarawak government to develop a green hydrogen industry in Sarawak. So we aim to leverage the state abundant renewable energy resources such as hydroelectric power for the green hydrogen for domestic and international market. Okay, it is part of state punya broader effort to transition to low carbon economy and reduce greenhouse gas emission. We are going to be the leading player in the global green hydrogen market. And currently we have the first integrated hydrogen production and refueling station that is owned by Sarawak Energy Berhad. Okay, this is available right now in Kuching. Very soon we will have another multi-refueling station in Darul Hana, Kuching. Okay, it's owned by Petros. They also have the hydrogen refueling station. All right. I would like to quote this quote from World Bank. Sustainable cities are resilient cities that are able to adapt, mitigate, and promote economic, social, and environmental change. Okay. Going to this, you can see that the top cities with best public transport. You can see that the Oslo, London, Stockholm, Berlin, Zurich, Paris, Hong Kong, Singapore, our neighbor, plus the Tokyo, all of these cities, they have the ridership is more than 60%. This is what we are aiming to be in future, hopefully, inshallah. Okay, maybe next part, introduction to the hydrogen mobility. So what is the principle of hydrogen and fuel cell? Okay. So hydrogen is an energy carrier. Hydrogen stores and delivers energy in easily usable form. Simplest element on Earth that made up of one proton and one electron. So it is the most abundant element on Earth's surface. That makes up 90% of the universe. Okay. However, hydrogen itself is not sustainable source of energy. It does not easily freely in nature. It must be extracted from other compounds lah. Okay. So the hydrogen itself is colorless, non-metallic, non-toxic, like lightest gas. It is a lightest gas. Highly flammable, odorless, and tasteless. Okay. So at all time, we have to make sure that there will be no cloudification of hydrogen, because in which if the cloudification of hydrogen achieve more than 18%, it will result detonation lah ke bumi. Okay, there is something that we need to avoid. I will talk about this later on the next slides. Okay. Okay, there is many types of hydrogen color wheel. Color we have right now. There are a few types of hydrogen. We have all the colors here: green, blue, gray, pink, black, yellow, turquoise. And they are being categorized based on their method of production. Okay, in KUTS, we will focus on green hydrogen because it has zero emissions, sustainable, and can be renewable. Okay, types of hydrogen. I will bring you this to these three famous hydrogen for gray, blue, and green. Okay, for the first, in terms of method of productions, gray hydrogen and blue hydrogen, they will split natural gas into hydrogen and CO2. However, for green hydrogen, it comes from the electrolysis with renewable energy. The source daripada hydrogen, hydropower or wind lah for time being. Okay. Solar is not considered as green anymore. Solar already under yellow hydrogen. Okay, for CO2 emission, grey hydrogen, they will have a high emission because the CO2 will be emitted to the atmosphere. While for blue hydrogen, we reduce the emission via carbon capture and it will be stored. Okay, but for green hydrogen, we don't have any CO emission, it's zero emission. Okay, in terms of sustainability, grey is not really sustainable, blue is partially sustainable, and green, yes, it is sustainable. Energy source also is a non-renewable for both blue and green. Green is renewable. And in terms of cost of productions, for time being, we can see that gray is very low, and then blue is moderate, and green is considerably high because of the technology itself. That is very soon it will getting lower, inshallah. Okay, a big principle of hydrogen fuel cell. You can see there is a animation here to assist you to understand. All right, the hydrogen fuel cell stacks consists of few major parts. There is anode here. Okay, there is a cathode around here, and there is a proton exchange membrane. So this is the main parts of the hydrogen fuel cell. So hydrogen atoms will enter the anode. You can see here, entering to the anode, and then it will strip off the atoms, in which the positively charged will pass through this proton membrane exchange membrane, and for the negatively charged electron is forced to pass through the the circuit that will generate the electricity. Okay, after passing through this, the electron will combine with the proton and oxygen from the air. This will generate the byproducts, air dan heat lah. Okay. All right. So this is the basic principle of how hydrogen fuel cell generate the electricity. Okay. I'll move to the next one. So this is a bit overview of hydrogen technology. You can see on the blue side, the blue color is showing the production of the hydrogen. From this picture, it's using the electrolysis method to produce the hydrogen. Comes from the renewable energy here, and then we'll go. This is on the production sites to store all the hydrogens, and then it will pass through the pipelines or for the transportation of hydrogen for the distribution. And then on the blue side, you can see maybe the first part is on the mobility. There's hydrogen powered fuel cell, can be used on trains, cars, trucks, buses, and so on. Even we have the hydrogen bicycle, you know. This is okay. This is part of the decarbonizing of the industrial process. You can use the green hydrogen. It also show the conversion of hydrogen in the stationary fuel cell system here, right? And also the combustion of the hydrogen. This is the combustion of hydrogen. It can produce the electricity for any area, any residential or any commercial area. All right. Next slide. So introduction to hydrogen mobility and hydrogen fuel cell powered autonomous rapid transit. What I'm going to share with you here is like it's a prelim information. We are still in final design. It's not finalized yet, but this is overall, and most of the aside from ERT, similar like what we have in other railway transportation system. Aside from this, even Alstom Krakroda Island is one of the train currently in service for hydrogen, using the similar method and approach. Okay. In here, okay, you can see that this is the layout of ERT. We have hydrogen fuel cell on top of the roof of the ERT, and then next to it is hydrogen tank. We also have the HV battery here, high voltage battery, to drive the motor. Okay, in terms of configuration of before that, sorry, the configuration of our ERT is 3-car ERT. We have MC1, motor car, motor and motor car, and MC2. So based on this, as I mentioned just now, we have hydrogen fuel cell, we have hydrogen tank, HV battery, and all the hydrogen equipment is in the motor car 1 and motor car 2. H2 receptacle is at the side of the ART. Okay, and then this is HV battery charger point usage for the maintenance. Okay, so the hydrogen is stored into these two fuel tanks at 70 megapascal. And then the fuel cell system will convert the hydrogen and oxygen that will produce the electricity and water and heat. Okay, and the third one, the produced electricity energy will be used to propel the system, and then stored in the battery system together with the auxiliary power supply. Okay, primarily this for our ERT we have 110 kilowatts of hydrogen fuel cell system. Actually, it's supplied by this 4 tanks of 14.6 kilogram type 4 hydrogen cylinder. It is stored at 70 megapascal or 700 bars. And then this battery, we are using the lithium iron phosphate. It's a high voltage battery. So for these 4 tanks, it can travel up to 200 kilometers between refilling. Okay. All right. This is the hydrogen fuel cell system powertrain typical architecture. Okay, this is the ART that we have currently in Kuching for the POC, proof of concept. So from the side we have the hydrogen storage on top plus the fuel cell, and then we have the HV lithium battery also on top. LV battery, the small scale battery, we have at the front, both here. And then this is a traction inverter and traction motor at every motor train. Okay, we have here, and here. All right. Okay. This is the typical architecture of the hydrogen fuel cell. Maybe I will explain a bit. The hydrogen filling, we have the filling receptacle at the side here. All right. H2 gas is pumped into the tanks of the H2V by a nozzle and receptacle. So as I mentioned, the hydrogen, when it comes into the hydrogen storage container, we store at 70 megapascal. Is considered this 70 megapascal will allow us to travel that 200 kilometers, right? Because if we refer to other like buses, mostly they are using 350 megapascal, But for us, we are designing it to use a 70 megapascal for ART. Okay. So we have the regulator. Okay. In this storage container, hydrogen tanks, there is a few safety system within the tank itself. We have a shut-off valve here. We have a TPRD, uh, thermal pressure relief device. If anything happen to the system, let's say there is an overpressure or there is a over temperature detected by the system, shut-off valve will cut the supply, the hydrogen line supply to the fuel cell, and then it will automatically enable the TPRD will release automatically all the hydrogens out from the system. Okay. And then this is regulator from the 70 megapascal, it will be reduced to below 10 megapascal into the fuel cell system. Okay, at 10 megapascal, it will enter the fuel cell system, and then all the process that I already explained just now in previous slide, hydrogen will react with oxygen inside the fuel cell and generate the electricity and water. Okay, so electricity, water semua keluar kat sini lah nanti. Okay, and then from the output from the fuel cell, it goes directly to energy management system. From here, okay, fuel cell will charge the lithium battery, and then from the EMS, energy management system, it will provide the electricity to the traction motor, and the traction inverter, and from traction inverter to traction motor to drive to propel for the propulsion of the train. Okay. Aside from that, there will be also the low voltage DC and or auxiliary of high voltage AC. There will be the low voltage to assist in the management of the ART itself. Okay. The HV is to drive. Okay. Just for information of everyone, aside from the 4 tanks of 14.8 kilogram hydrogen tanks type 4 that we have, we also have the battery that will assist us to drive another 50 kilometers. So in total, the ART can travel up to 250 kilometers, right? Because we need the tank, the battery to assist us during the emergency if anything happen to the hydrogen system that because of failure lah, right? And then the battery, there will be a regeneration brake to send the energy directly back into the battery for the regeneration. So this is normal. This is similar like what we have in other railway projects or most of railway like MRT. There's a regeneration. For this part, Dr. Zhu boleh explain. Dia memang expert lah. Alright. Okay, few facts on hydrogen fuel cell powered ERT. What is the H2 refilling time? So the refilling time will be 20 minutes per fleet. Alright, that is a design that we are putting in for the contractors for them to fulfill. And then system efficiency. Currently, based on the design, we managed to achieve 50 to 60% of efficiency. This, if compared to combustion engine, it will only achieve at 15 to 25%. In terms of operating range, it can travel up to 200 kilometers between refilling, plus 50 kilometers if using battery. All right. I already mentioned about this. The storage tank is, we have 4 times 14.6 of type 4 hydrogen cylinder at 70 megapascal. This is for the CO2 emissions. This is fun fact punya information lah. 0, we don't have any. So by 2030, KUTS will avoid 55 kiloton of CO2 emission. Okay, currently on the hydrogen purity, as we are using the green hydrogen will have the purity of 99.995%. Okay, so talking about the CO2 emissions, simple calculation based on we have the numbers 35.1 gram of carbon emission per passenger per kilometer. So based on this 35.1 gram, each of the ART will produce will avoid of 4,200 kilogram per fleet per day for the sake of for the current population. So in total, that's why we get this 55 kiloton of CO2 emission by 2030. Okay. All right. A bit of information what we have in Rembos Depot. This is any railway type projects like even ART. We have depot to store all of our ART. Okay, on the top side here, you can see this is a stabling yard. We have our ART to be simpan kat sini lah. Out of operation during engineering hours, it will transfer back here. Okay, we also have the this is the maintenance workshop, light maintenance workshop in front here. This is an admin building, administration building, and then this is the refueling hydrogen refueling facilities. This is the crucial part because without hydrogen we can't operate, right? At the back end here, this is called purging area. So when we have the hydrogen required to be required for maintenance, it will travel back to this purging area to purge out all the hydrogen. When we don't have the hydrogen within the system, then the hydrogen is allowed to come into the maintenance facility. Okay. Okay, I already mentioned about this. Maybe this behind here, we have the hydrogen production plant. This is currently being built by our sister company, SEDC Energy. They are the owner of Petros as well. So very soon they will have the plant here. They are planning to produce at least, I think, if not mistaken, it's around 5 tons per day for our usage of KUTS. Okay, all right. Maybe emphasize a bit. This is the hydrogen refueling station. Kat sini kita isi hydrogen tu. So every time the train will turn back from the alignment ni this side, entering and then pusing, kita pergi to hydrogen refueling station, they fill up. Okay, currently based on our simulation studies, it might be 2 kali refueling for for 1 day operation. So dia akan isi and then dia akan patah balik to the main line. Okay. Second is the purging area. I already mentioned just now. Kita perlu for purging area ni before the RT can safely enter to the maintenance building. Kenapa kena purging? Because of hydrogen is highly combustible, and then we have to remove the hydrogen from the system. We will purge using the nitrogen, and then after around 5 times of purging cycle, then we will allow the ART to come into the hydrogen facility, the maintenance depot. Okay, maintenance depot, more or less, maintenance facility is similar like what we have with other railway projects of maintenance depot. The only special a bit about KUTS ART hydrogen system, we have the hydrogen workshop within the facilities. So this workshop is specially designed to ensure safe maintenance of the hydrogen fuel cell and its system. It has all the safety devices. For example, they have the hydrogen leakage detection system and proper ventilation system within the workshop. Okay. Okay, the last one is I already explained about this. This is hydrogen electrolyzer plant. Currently being built by our sister company SEDC Energy. Okay, maybe a bit sharing on the infrastructure design recommendation. Actually, this is extracted from my own thesis. for my master thesis regarding the infrastructure design recommendation. Okay. The first part is hydrogen refilling facilities. It's a must. We must have the hydrogen refilling facilities to ensure that we have the sufficient, we can refuel our hydrogen ERT, hydrogen fuel cell ERT, or even train. I think I'll move to the next one because this will come with all the pictures. All right. Maybe the first part, infrastructure design recommendation. The first one is no roof structure above the ERT or the train. Okay. This is the first recommendation because this is based on the position statement made by Compression Gas Association, incorporated in US, United States of America. They have this Compression Gas Association, PS 46 2022. They gazetted that there shouldn't be any structure above the stationary hydrogen tank system. So this is applicable to the stabling yard, our stabling yard. So when we have the or even the hydrogen refilling, we try to avoid to have this structure, permanent structure above the train. Okay. This is because of number 2. Let's say if any of the hydrogen tank or hydrogen piping system, there is a leakage. This leakage is at 10 megapascal, or even for the tank itself at 70 megapascal. It will create a jet flame or even heat flux. So for this, we have to ensure we have a safe separation between the train or ERT itself with the depot infrastructure. So with this, it is because 70 megapascal, we are using different pressure system for the tank. We require different approach. If you're using 35 megapascal, it will not the same with what we are using 70 right now. The safe clearance on top of the gap between the top of train and the depot infrastructure. All right. So to gather the information about this, we have to conduct the quantitative risk assessment based on the characteristic of the ERT itself. From that QRA, we will have these jet flames and heat flux on how these two events to ensure the self-separation between the train and the infrastructure. Okay. On next item is on the electrostatic discharge. ESD is required at all hydrogen fuel filling facility or even hydrogen workshops. All right. This from the example here we have, this is the hydrogen refilling station. They have a ESD in the middle of here. Okay, this is grounded to the earth. All right. On the third one, yeah, under I think this is third, and then the fourth one is on the stack ventilation concept. Okay, we have to use this stack ventilation concept at all of our infrastructure. We have this at our depot. We also have this approach at our station, especially those covered station. We have 2 stations. Our main station at my exchange is adopted this approach. Right. This stack ventilation concept will allow the high pressure movement to the low pressure in this manner. And then if we have our hydrogen vehicle within the area, if there is any leakages from the hydrogen fuel cell system or the tank itself, the hydrogen will flow according to this airflow. All right. Next one is on the hydrogen purging facilities. Okay, as I mentioned just now, we have the purging area. We will use we can use nitrogen. Currently, we are using nitrogen. At first we will release the hydrogen to the atmosphere, if you want to allow the ART to come into the maintenance facilities or maintenance workshop, we will purge out the N2. We will purge in the N2 into the hydrogen system and purge out the I'm sorry, I need to repeat this. Okay. We have to let the nitrogen to comes in into H2 system and purge out the hydrogen. Okay. Right. This will be done at the hydrogen purging facilities before entering to any maintenance workshop or maintenance facilities in the depot. And last one, last recommendation. There is more, but this is the most important out of all the recommendation I can give. Is to have the hydrogen leakage detections in where we have the hydrogen system will be stations. Okay, permanent station. For example, at near the hydrogen purging facility, we might need to have this hydrogen leakage detection system. At the hydrogen workshop, we need to have this hydrogen leakage detection system so that it will automatically detect if there is any hydrogen within the area. So we are recommending that all of the system to be the leakage detection shall be the safety integrity, have to achieve the safety integrity level, SIL, system when it is equipped at any of this facility. Okay. To assist, this will assist the jet fan. Usually, for example, at this stack ventilation system, usually we will have the jet fan around this area. When there is a hydrogen leakage detections activated, they detect there is hydrogen. We will ensure the jet fan will be activated to assist the airflow to allow the hydrogen goes directly into the atmosphere. All right. Okay, I talk a bit on the system assurance in KTS. So the main objective of the system assurance is number one, to ensure safety. Number two, ensure safety. And number three, also safety. So basically, system assurance is to ensure that we have a safe system for the safe operation of KTS. Not only safe operation, safety is contributed to the reliability, availability, and maintainability of the system. Okay, there's few elements here. I think I will touch a bit on this left side. On system safety, we conducted the hazard and risk identification. It covers entirely everything on anything related to train mobility system or even ART. And then we have a risk identification and hazard identification for hydrogen. We try to capture as much as possible and provide a safety mitigation to ensure that all the risks can be lowered down as much as possible. All right. Aside from that, I think I already mentioned about this, the reliability, availability, and maintainability, because based on RAM principle, we will ensure we have a safe and smooth operations later on. And then in terms of verification and validation, we try our best to ensure the system is being built according to the specs, right? We will make sure the consultant contractors is compliant with all the requirements. There will be a stringent testing and commissioning will take place for entire project lifecycle. Okay, when you say about this, the first part, quantitative risk assessment, required to conduct this QRA if there is any specific safety related system or functions. We did this QRA for the hydrogen system, even on the onboard system itself, or how the hydrogen system fuel will react with other facilities. This is also being done. And then we have also fire life safety study that shall covering the NFPA 130 as a basis for fire protection system. Right. There are also other hydrogen related standards that we have to comply with. Other than that, we also have software management and control, cybersecurity, configuration management, and change management to ensure a safe and reliable operation of KUTS. All right. The objectives of hydrogen for QGS. I think this is almost the end of my presentation. We try to minimizing the environmental impacts. With this project, we hope that we can help to drive down the cost of technologies. We aim for zero greenhouse emissions. We try to reduce the carbon footprint of having ART in Kuching and powered by hydrogen. This is also to promote the growth of renewable energy. And then for Sarawak, we try to reduce dependency on fossil fuel. And the last, hopefully this project will allow for hydrogen to be more accessible. With this, I end my presentation. Thank you very much. Back to you, Dr. Zul.
Okay, terima kasih. Thank you. TS Khairul Syahir atas pembentangan yang beliau berikan sangat-sangat kita dapat tahu benda-benda yang baru lah. Selama ni kita kalau dekat Malaysia ni dari segi pengoperasian lebih kepada electrification ni, macam mana kita nak generate daripada hydrogen menghasilkan elektrik. Baru tahu tadi kita nampak ada hydrogen pun ada grey, ada blue, ada green. So, saya rasa ni satu perkongsian yang baik lah untuk para pelajar dan hadirin yang hadir lah. Okey, so saya buka untuk sebarang pertanyaan lah. Kot ada pertanyaan daripada para pelajar ataupun jemputan yang hadir pada sesi hari ini. Kalau tak ada pun boleh letak dekat chat, saya boleh bacakan lah. Sebelum tu saya nak tanya.
Kalau
Saya nak
saya tak
tanya
dapat
lah.
jawab, saya ada saya punya hydrogen punya support kat sini.
Okey, saya nak tanya TS Syahir lah. Dalam bahasa mudah lah kan, mungkin kadang orang tak faham hidrogen. Air lah kan hidrogen sebenarnya H2O tu dalam menghasilkan elektrik ni untuk untuk menggerakkan art dan bas ni. Boleh saya tahu tak berapa dia punya kapasiti air yang digunakan untuk bas dan kapasiti air yang digunakan untuk art?
Kapasiti air Oh, information tu, sorry doktor, for the information saya memang tak ada berapa banyak air yang dipakai tu. Because this study is being covered by our sister company, SCDC Energy. So they are the one yang akan produce the hydrogen for us. So untuk kita, for us, for KUTS, currently kita aim from our simulation and calculation, we will use around 5 ton lah, 5 ton sehari untuk operation kita punya ART dan juga kita punya bus.
Okay. So ada soalan tak? Macam faham je semua ni ke dia punya panel nak kena soal balik? Nak kena soal hadirin sekalian. Isa, ada soalan tak Isa? Saya panggil nama student saya ni sebab dia orang datang hari ni. Ada soalan tak kepada TS Syahir?
Pada saya ada soalan dia tapi dekat infrastructure design recommendation tu apa yang dimaksudkan terms purging hydrogen purging facility purging tu lah.
Purge. Purging tu maksudnya buang. Kita nak disperse, kita buang hidrogen daripada sistem. So bila kita nak maintain, kita sebab saya ada inform daripada awal tadi, kita tak nak hidrogen tu ada clouding effect. Kalau dia leakage, dia akan terkumpul menjadi cloud, jadi awan. Kalau at certain area, dia punya percentage increase up to 18%, it will come to detonation. dia akan meletup. So to avoid that, kita kena make sure yang hydrogen ni always release to the air lah. Kita tak nak dia dia reach that certain percentage. Sebab tu kita kena purge out. Kita purge tu maksudnya buang lah, kita buang daripada sistem.
Okay. Thank you, Cik Khairul.
Sama.
Okay. Nafis Idlan, boleh bagi soalan?
Assalamualaikum. Tuan, saya ada satu soalan.
Assalamualaikum.
Berkaitan dengan purging juga. Just now, Tuan ada mention, purging process tu it must only be done through nitrogen kan, betul? I mean to neutralize hydrogen from being combustible lah. Is there any other method untuk buat purging tu other than nitrogen?
Kita boleh guna gas lain, macam CO2, kita boleh guna CO2. CO2 pun boleh digunakan, tapi nitrogen, kita pilih nitrogen sebab nitrogen is the safest lah. Sebab macam CO2, kalau kita boleh guna, actually kita boleh guna any inert gas for purging purposes.
Alright.
So selain daripada inert, jadi yang kita pilih nitrogen sebab dia the most safest inert gas. Kita boleh guna juga CO2, tapi we try to avoid CO2 sebab CO2 kalau terlalu banyak kat satu tempat, it can harm your health lah. So that's why we are choosing nitrogen tadi.
Okay Tuan, clear. Thank you.
Okay. Okay, terima kasih Nafis. Tadi kalau kita dengar pun sekarang kita tahu on railway kan decarbonization. Sekarang kita tengok daripada arts ni pun nanti by 2030 dia dapat jimatkan, dia dapat avoid 55 kiloton CO2 emission. So berapa banyak dia boleh elakkan CO2 emission tu Okay. Ada soalan lagi? Nagesh?
Assalamualaikum Tuan.
Salam.
Ya, nama saya Muhammad Izzat. Saya nak tanya berkaitan dengan kos pula. Sebagaimana yang saya terbaca, kos kita untuk pisahkan hidrogen dan oksigen daripada air itu sendiri sebenarnya lagi tinggi daripada tenaga yang akan dihasilkan oleh hidrogen itu sendiri. Jadi, kalau boleh secara general saja Tuan, macam mana untuk pengurusan kos pula? Adakah dia berkesan untuk sebagai public transportation?
Okay, bagi saya cerita dulu dalam konteks Sarawak. Untuk di Sarawak, kita ada extra electricity yang sangat tinggi. In which kita ada beberapa dam, Bakun Dam, Bali Dam. So ada banyak dam ni. So this hydropower is a renewable energy yang technically, contohnya kita ada certain percentage, 70% is not being used. Kita guna sekarang yang 70% yang kita tak pakai ni. So that's why in term of cost, kita anything to add? Sekejap, saya ada import juga Okay, one more thing. We need to create a demand dalam okay.
Currently, the cost is more on the technology because not much of the usage of hydrogen. So when the Sarawak agenda is more focused on the hydrogen, so it will help drive down the cost of energy. It is true that the hydrogen cost is still high because there's not much demand on the hydrogen itself. But when we embark into the hydrogen technology, so Sarawak will be focused on it, and then we try to help down the cost of the technology. Actually, the technology is most on the hydrogen production because there's not much of the company that produce the hydrogen currently. But what Sarawak doing now is to down the cost of the technology. So as as Khairul said that Sarawak has an abundance of renewable energy from the water because there's a lot of river here, so there's a lot of water here. So we are not much on the cost of the water, but maybe cost of the electricity itself. But because the electricity is using the hydropower, so the cost is still not that high. But the cost of the technology itself, like the compressor, the electrolyzer. Actually, there's the compressor and the electrolyzer is already there a lot of in Europe. Only in the Asia, we are still a little bit lag. But the China is currently progressively into the technology. So most of it we go into the China currently. I hope it answers the question. And one more thing, we are trying to levelize the cost of the hydrogen. So when we try to levelize the cost of the hydrogen, what the currently government is trying to do, so that the cost of the electricity also will be low.
So yang penting sebenarnya we try to create the green hydrogen economy. Bila green hydrogen economy is created, it will create a better supply and demand. In a way, it will reduce the price cost of the green hydrogen too. That is the target lah. But in the end, our main aim is for sustainable. We need this green hydrogen for sustainable. Kalau kita tengok other technologies, maybe like solar, lama-lama nanti, or even battery, the lithium supply is limited. We try to limit the usage of lithium lah. Okay. Even solar punya photovoltaic punya material, at sometimes it will deplete, and currently we have the only solution we have right now is the hydrogen, which the hydrogen itself is the sustainable supply that we have. It's only that we have to reproduce it lah using the electrolysis.
Okay. Kita ada Hajatul. Hajatul nak bertanya ke? Cik Hajatul?
Ya, saya doktor.
Okey, sila.
Tak nak tanya apa tu?
Pak, saya nampak awak angkat tangan ni.
Bukan saya.
Bukan okey. Encik Basri ke?
Ya, betul. Cik Basri yang angkat tangan.
Encik Basri. Sorry Hajatul.
Tak apa.
Ya, boleh nak tanya 2 atau 3 soalan lah. Satunya untuk fuel cell ART ni, dia apa risiko untuk explosion fuel cell ART ni, dan macam mana kita nak protect daripada explosion? Saya assume pasal hydrogen rating explosion dia 3 lah. Dan adakah ART akan gunakan explosion proof punya material?
Okey. Itu ya 3 soalan dari Encik Basri. Yang pertama, risiko to explode. how to protect from explosion, dan adakah akan guna explosion yang satu tadi saya tak dapat tangkap.
Oh, explosion proof.
Explosion proof, okay.
Okay, saya jawab benda senang dulu. Yes, ERT akan menggunakan explosion proof punya material. Bukan setakat dalam ERT itself lah. Even dekat kita punya maintenance facility pun akan menggunakan explosion proof punya material or EX. And then jawab soalan pertama. Ya, memang risiko hidrogen agak tinggi. They have it's a highly combustible punya material, punya element. Sebab tu kita conduct quantitative risk assessment. Dalam quantitative risk assessment ni, kita akan study kesan akan berlakunya leakage, macam mana, apa akan berlaku, macam mana nak mitigate pun akan provided, recommend di dalam QRA itu sendiri. So menjawab yang tadi tu, kita ada safety mitigation being implied untuk semua hazard-hazard yang ada. Kalau ada leakage at certain percentage, what we have to do. Contohnya macam tadi saya beritahu, apabila berlaku leakage, automatically kita punya tank akan, dia ada device nama TPRD, Thermal Pressure Relief Device. Dia akan automatically release the hydrogen to atmosphere. Bila kita release to atmosphere, kita akan mitigate the combustion daripada hydrogen tu. And then kita try not to allow any cloudification ataupun hidrogen tu jadi awan lah, dia terkumpul dalam satu tempat lebih daripada 18%. Untuk certain area yang mungkin ada risiko cloudification ni, kita akan letakkan hydrogen sensor, hydrogen leakage sensor. So sensor ni akan detect, kalau dia detect almost 5% hydrogen existence dekat satu area tu, automatically kita punya jet fan system akan activated, dia akan release all the hydrogen to atmosphere. Other than that, saya dah jawab soalan 1, soalan 3, soalan 1. Yang kedua tadi
How to
berkaitan
protect
dengan
from explosion. How to protect from explosion. Dia punya soalan dia. Maknanya
okay,
ialah
how to
hidrogen tu
protect
kan.
from explosion.
Boleh saya bagi contoh tak? Contohnya kalau dalam oil and gas lah kan, kita akan buat section area. Kalau dalam rolling stock, adakah kita akan buat section area? Maknanya explosion area, passenger area, system safety area. Pasal dia akan jadi zone by zone lah maknanya.
Okay, kalau kita tengok pada ERT sendiri, keseluruhan hidrogen punya sistem kita letak di bahagian bumbung. Kita tak letak dekat bawah ataupun dalam kabin, area kabin itu sendiri. Semua dia letak bumbung. Jadi kalau dia ada bila ada kesebaran kebocoran atau leakage, hydrogen punya nature dia akan release tu ke atas. And then disebabkan oleh pressure rise daripada TPRD itu sendiri, 70 megapiksel, hydrogen tu akan dia akan okay, saya tunjuk saya tunjuk satu gambar je. Okay, kan nampak gambar di sebelah, okay, this one. So bila berada di atas bumbung, hydrogen tu akan release ke atas. So bila dia release ke atas, ada certain operation yang kita akan make sure lah, in term of operation. Kalau train detect there is a leakage detection, train operation tak boleh entering to the station operator, sebab tu kita ada driver on board yang akan monitor the alarm lah, event tu. And then like you said just now, betul, kita punya all hydrogen fuel system will be on top of the train. This will be considered as a safe area. Kat bawah ni akan be a safe area for the operators, for the passengers, sorry.
Okay. Cik Basri.
Okey.
Okey. Ada soalan lain? Student ni kadang-kadang dia malu. Jangan malu bertanya, nanti lepas kelas nanti habis dia tanya saya macam-macam. Kita tanya pada yang pakar. Nagesh, mohon kemukakan soalan.
Doktor, maybe boleh saya share sikit lah.
Boleh.
Berkaitan dengan hydrogen tank type 4 tadi tu. Tank itself, kalau dia terbakar, dia boleh withstand up to 2 hours. Artinya hidrogen di dalam tu, kalau dia ada hidrogen dalam tu, nothing happen lah. Tak ada apa-apa yang berlaku. That is safety feature yang ada pada hydrogen tank type 4 ni.
Maknanya dia macam dia proof lah. Maksudnya dia akan terbakar dalam tu je. Dia takkan terkeluar.
Fireproof dan dia je explosion proof. Tank itself. So sekarang ni kita kena kata safety measures untuk dia punya piping system lah. The outside daripada tank. Tank itself is very safe. Macam saya cakap tadi, dia boleh cater 2 hours of fire, and then dia ada thermal pressure relief device ni. Kalau 70 megapascal ni untuk 14 kg, kalau kita release the pressure less than 1 minute, the entire hydrogen tu dah kosong dah tank tu.
Sangat menarik tu. So dia punya safety dia tu terjamin lah Dia mengikut standard yang sepatutnya lah. Okey.
InsyaAllah.
Saya minta soalan ni daripada pelajar saya ni. Ada lagi yang nak bertanya soalan ataupun boleh letakkan dekat chat box?
Saya nak tanya.
Okey.
Ini in context of environmental lah. Since hydrogen is a greenhouse gas kan. Maintain ozon apa semua, and then dia akan jadi satu, saya ni baca dekat Google, dia kata bila hydrogen dengan greenhouse gas, dia akan efek dia akan sama juga, akan cause global warming. So dekat mana yang hydrogen ni akan ubah dan environment?
Sekarang ni yang the most yang akan menyebabkan global warming is pelepasan karbon dioksida ni. CO2 is the culprit sekarang ni yang terlalu banyak generation of CO2 emitted ke atmosphere. So kita nak kena kurangkan emission of carbon ni dalam atmosphere. Kalau kita emit hydrogen tu, hydrogen H2 tu is still 78% punya elemen di dalam atmosphere. Kita ambil balik dan kita release. It is the same. Tapi yang kita nak kena reduce is carbon itself sebenarnya. Sebab tu kita gunakan green hydrogen. Jangan guna grey hydrogen. Kita try to avoid guna blue hydrogen. Sebab this hydrogen 2 ni ada element of carbon. Dan carbon ni yang buat kita contribute to the global warming tadi.
Alright, terima kasih. Dr. Zuraida mute tu.
Hydrogen leakage detection. Dekat sini kalau kita tengok dekat sistem ni dia ada hydrogen leakage detection. So berapa bacaan yang dia boleh, minimum bacaan yang dia detect ada leakage dekat situ? Sebab kita nak tahu, kita nak consider dia punya minimal effect bila kita detect ada leakage dekat situ.
Okay. Efficiency of the hydrogen punya device, efficiency dia 90%. Okay. And then untuk dia detect, the system will detect 1 to 4% of hydrogen existent dekat certain area. Bila dia detect this 1 to 4%, automatically dia akan sense that as alarm. As much as possible, dia tak boleh reach more than 5%. Kalau dia reach more than 5%, akan ada spark lah. Tapi when it comes to 20%, dia akan jadi detonation. So kita nak kena monitor the hydrogen level tu as low as possible.
Okay. Dia ada sistem ni ke je ataupun dia ada redundancy system untuk
untuk hydrogen leakage detection ni sebenarnya dia akan pairing sama ada dengan building management system atau SCADA. Ada dua ni lah. Ni untuk dekat depo ataupun infra lah. And then dia ada multiple sensor. Dekat satu area tak boleh satu je. It must be more than one lah untuk ensure redundancy dekat satu tempat tu. And then aside from that, leakage detection system ni dia kena seal compliant. Safety integrity level, seal compliance. So far kita set seal 2. Seal 2 ni kalau dia fail, dia akan dia ada seal 1 until seal 4 lah. Seal 4 tu the highest. Okay, for seal 2 system, kalau dia fail, dia akan menyebabkan kematian. Okay, seal 1 dia menyebabkan satu kematian, seal 2 more than 2. So, kita kena make sure sistem tu seal compliance lah. Memang kita put, bila kalau kita buat risk assessment, there is some based on EN 50126 punya standard lah kan. EN 50126 ni dia akan fall under seal 2 usually for the hydrogen detection system. And then of course configuration dia redundancy, kena satu bilik tu at least ada 2. And then dia punya controller itself is monitored in term of its redundancy. Artinya dia tak pakailah satu PLC saja. PLC punya configuration must be 2 in nature so that dia akan parallel connected. Dan kita monitor that connectivity. Bukan cakap pasal redundancy ni, banyak lagi topik ni.
Okay. Yelah, pasal sistem keselamatan ni kan kita biasa ada redundancy kan.
Betul. Kalau tak dia jadi macam ni lah, 737 Max. Dia punya sensor dia ada satu je kan. Tu yang dia menjunam tu.
Okay. Ada lagi soalan? Kita punya sharing knowledge session ni pun agak full house hari ni. Ramai yang attend hari ni. Mungkin topik ni topik yang baru dan hangat lah. Banyaklah yang nak tahu berkenaan dengan art di Kuching Urban Transportation System ni juga.
Tak lama lagi Semenanjung pun ada kan.
Itu yang kita nanti-nantikan kan. Sebab teknologi berkembang kan, sebab kita menggalakkan decarbonisation, kena sampailah juga dekat Semenanjung ni. Nanti kita boleh guna kepakaran Cik Syahir lah kalau ada. Okey.
Kita boleh tolong.
Okey, ada lagi soalan? One last question.
The last question. Hello, dengar ke?
Dengar.
Okay, saya nak tanya luas sikit lah daripada hidrogen ni berkaitan dengan sistem ART tu sendiri. Kita tahu yang ART ni dia punya headway tadi 8 minit and dia punya traffic control tu dia integrate dengan local road lah. So jadi macam mana nak kekalkan headway 8 minit tu sedangkan kita lalu dekat kawasan yang trafiknya agak sesak. Contoh macam dekat traffic light. Terlalu dekat roundabout, macam tu lah.
Okay, macam ni. Sekejap saya cari slide yang ke belakang sikit. Okay, actually ART ni sendiri dia ada, okay, kita gunakan signaling system. Currently is running untuk signaling dia gunakan GOA2 punya gunakan GA2 lah punya principle. And then kita integrate dengan TSP, dipanggil Transit Signalized Priority. Jadi bila ART passing through mana-mana traffic light, dia akan mendapat priority untuk pass through the traffic light. Itu yang kita gunakan. Sebab yalah, technically ART ni lebih kurang macam tram, smart tram. Semuanya saya rasa almost the alignment will be at grade. So kita akan sharing side by side dengan kenderaan. Dia ada dedicated lane dia sendiri, tapi pada masa yang sama dia akan sharing lane, sharing area dekat traffic light area. Dekat situ lah. Yang menjawab tadi tu, satu dia ada signaling system untuk regulate dia punya movement. Second, dia ada traffic signalized priority. TSP ni akan berikan priority kepada ART untuk pass through semua traffic light. Dengan cara ni kita target for 8 minit lah.
Oh, faham. Maksudnya dia ada tak any samaan macam level crossing punya sistem?
Level crossing ada dia. Level crossing punya sistem akan ada dekat green line mostly. Tempat lain semua ni lebih kurang transit signalized priority ni memang level crossing lah. Artinya kita akan pass through the traffic any junctions. So junction ada traffic light. So traffic light tu akan berikan priority hijau untuk kita pass through. Memang ada challenge lah kat sini sebab this will be the first juga in Malaysia yang akan menggunakan transit signalized priority punya function sharing dengan public road.
Tapi art ni dia ada laluan dia sendiri kan, T.S. Syahir?
Yes, dia ada laluan dia sendiri, tapi dia akan pass through at least ada lebih kurang 61 junction. Sebab dia, so 61, lebih kurang 61 lah. Kita akan pass through junction. So kat junction tu stop, kita akan buka enablekan traffic light untuk dia lalu. So by right, dia takkan berhenti lah. Dekat semua junction dia akan lower speed around 30 km/h and then dia akan pass through the area. So lebih kurang 7 saat, 7 ke 10 saat lah untuk ART ni melepasi setiap junction tu. Yang ni, topik ni bagus untuk signaling. Kita boleh create another session lah. Saya rasa yang ini boleh, sebab untuk TSP ni dia punya principle dia nak kena faham dia lebih sikit. Sebab saya cerita ni mungkin tak dapat nak tangkap, tapi kita ada dia punya slide lah yang dapat explain macam mana TSP tu function.
Okay, Nazri?
Faham.
Okay. Ada satu lagi soalan T.S. Syahir daripada pelajar saya. Dia tanya, dia tak kalau boleh jelaskanlah apa tu safe separation for jet flame and heat plugs.
Okay. Jet flame ya. Jet flame ni, betul. Okay, dekat slide ni nampak kan? Okay, jet flame ni maksudnya, contohnya dekat sini ialah tempat yang bocor, ada pipe yang bocor ataupun saluran tangki yang bocor. Kita assume mungkin untuk bacaan ini lebih kurang besar lubang dia lebih kurang 3.5 mm. Bila 3.5 mm, api yang terhasil, okay, mula dia ada pressure release dia. Bila ada spark dekat that area ataupun ada static discharge, ada static, akan menghasilkan api. So api ni yang dipanggil jet flame. Api bersama dengan pressure is called jet flame. So T.5 dia akan create around 8 meter punya tinggi punya api tu. Combination api dan juga pressure tu jadilah jet flame. Heat flux pula ialah kesan bila panas, kepanasan di sekitar kawasan tu. Bahang dia tu. Bahang is heat flux. Saya jawab soalan tak?
Boleh lah tu, saya sudah faham dah tu. Okay.
So heat flux tu ialah jauhnya okay.
Okey. So soalan dah tak ada kan? Dah menjawab soalan tadi Nafis Idlan. Okey. Okey, so kita pun dah sampai ke penghujung lah. So terima kasih kepada TS Syahir dan juga pihak Sarawak Metro lah atas this fruitful sharing session lah. So kita harap sharing session ni takkan terhenti di sini. Mungkin akan datang kalau kita jemput lagi untuk kita explain kepada pelajar-pelajar berkaitan dengan topik-topik yang berkaitan. Harapnya boleh membantulah kepada UTHM. Okey, dan sebelum kita mengakhiri kita punya program pada hari ini, saya nak minta isi kehadiran, dan kita nak ada sesi bergambar sikit lah. Kalau boleh tolong onkan kamera. Cik Syahir jangan serik lah. Harapnya lepas ni kalau kita panggil lagi, tadi pun ada topik yang menarik berkaitan dengan signaling tu pun.
Tak adalah, maksudnya bukan dia pakai.
InsyaAllah.
Dia pakai untuk. Jadi kalau ni Rayvon saja. Kan bagi dia kan. Kita pakai untuk Rayvon, Kati dan
Gambar.
Okay.
tadi tu dalam untuk apa ni?
Kat kamera Okay, Revan. Mungkin Revan boleh cakap ready ke apa ke?
Okay, ready 1, 2, 3. Sekejap Okay, next page seterusnya. Ada 6 page ni.
Ramai kita punya kehadiran hari ni.
Okay, ready 1, 2, 3. Ready 1, 2, 3. Okay, ready 1, 2, 3. Okay.
Okey. Okey, selesai sudah. So, terima kasih sekali lagi buat TS Syahir yang banyak membantu atas sharing session ni. So, terima kasih juga kepada para pelajar dan tetamu yang hadir. So, ada masa, ada rezeki, kita jumpa lagi dalam sesi yang lain. Okey, terima kasih. Assalamualaikum.
Terima kasih. Assalamualaikum.